The revelation of another conceivable Earth-like planet is gaining worldwide attention today. It's true. Scientists have recently stated their belief that there are other planets outside our solar system that resemble Earth in size and may have liquid water. However, this latest finding is the closest planet yet discovered. Yes, it's 4 light-years from Earth, just a mere 25 trillion miles away, but travel there might be possible before the century's end. Some thrilling news. Scientists say they found a planet orbiting the nearest star outside our solar system. They call it Proxima B, which is about 4 light-years away. It's a rocky globe that could have enough surface water to support life. This is the closest planet that possibly can support life and could be, in a way, like our own planet, researchers announced. We've discovered a terrestrial planet orbiting Proxima Centauri. The closest exoplanet ever found since Proxima Centauri is the closest star to the Sun. Scientists searching for life on other planets often refer to the Goldilocks zone. Not too hot, not too cold, but just right. NASA now believes Proxima B is squarely in that zone. This causes researchers to believe the potential for liquid water and life is there. It's extremely exciting because, among the catalogs of planets we have at the moment, this is the first chance we've had for an Earth-like planet in the habitable zone of a Sun-like star. The planet Proxima B orbits a small star called Proxima Centauri, as shown in this simulation. It is around 1.3 times the mass of Earth, probably rocky, and perhaps warm enough for liquid water. It is tidally locked, scientists explain, which means one side is always in daylight and the other side is perpetually dark. The land on the light side might be better for habitation, though for night owls, the dark side might be preferable. Although Proxima B is very close to its star, the star itself is a brown dwarf, a faint and cool star. As a result, the planet can exist closer to its star while still falling in the Goldilocks zone, where the temperatures are just right for water to exist in liquid form. Here's the key point to remember. Wherever we look on Earth, deep in the ocean or even in Yellowstone's acidic springs, if there is liquid water, we find life. Astronomers have now made a surprising discovery on the dark side of Proxima Centauri B, a side that has never seen the glow of its star. For years, it was assumed this side was merely a cold, lifeless shadow. However, recent observations suggest otherwise. Something faint yet unmistakably unusual is emanating from the darkness. Scientists using powerful telescopes such as the James Webb Space Telescope, JWST, are detecting weak emissions from Proxima Centauri B's dark side. What could these emissions be? These signals may take many forms: artificial light, heat radiation, or other types of electromagnetic radiation such as infrared. Unlike the natural starlight we typically detect, these signals have a unique signature that marks them as artificial or the result of a complex system. If these emissions are artificial, they could point to a technologically advanced civilization. For instance, the patterns of light and heat might indicate the type of technology in use, the scale of energy production, or even the social structures of the planet's inhabitants. Just as the city lights on Earth reveal our political boundaries and economic priorities, the emissions from Proxima B's dark side could tell us about a civilization's values and priorities. Moreover, the tidal locking of Proxima B plays a crucial role. Because one side of the planet always faces its star while the other remains in perpetual darkness, the dark side becomes extremely cold and inhospitable. For life to exist there, artificial lights or energy sources would likely be necessary to provide warmth and illumination. Future telescopes such as the JWST and the proposed Large Interferometer for Infrared Radiation (LIR) are designed to detect such faint emissions. Equipped with advanced technology, they can capture narrow bands of light in the infrared spectrum, making it possible to distinguish artificial emissions from natural starlight. Could these emissions provide the first evidence of extraterrestrial life? The possibility is thrilling and may soon offer us a glimpse into an entirely different way of life light years away. Stargazers, get ready for something undeniably thrilling: fake light. What sets JWST apart is its capacity to focus on specific wavelengths of light emitted by artificial sources. The infrared sensitivity of these telescopes means they can detect heat radiating from a planet, even from light years away. This is vital because the artificial lights that could illuminate Proxima Centauri B's dark side may emit heat that is detectable through this infrared lens. By examining these frequencies, astronomers can differentiate between natural starlight and the unique signature of artificial light. The ability to detect these faint emissions could mark a pivotal change in our search for life beyond Earth. We are not only discovering new planets but also potentially signs of intelligent civilizations. The technology behind JWST and OIR could help us identify a civilization on a distant world simply by detecting a pattern of light unlike anything we've ever seen. But what kind of technology would be needed to create these artificial lights on Proxima Centauri B? The implications of this discovery go far beyond detecting emissions. They could reveal the technology that enables life to thrive in an otherwise inhospitable environment, potentially making the dark side of Proxima Centauri be habitable. Extraterrestrial civilizations would likely rely on advanced technologies to generate light and heat. One possibility is the use of photovoltaic panels, solar cells that convert sunlight into electricity. Although the dark side of the planet doesn't receive direct sunlight, these panels could be installed on the perpetually sunlit side to harness solar energy and store it for use on the dark side. Other advanced energy sources could include nuclear fusion reactors, which produce vast amounts of power without relying on solar energy, or even artificial photosynthesis, an innovation that mimics the process plants use to convert light into energy. These artificial lights would serve two critical functions: providing light and warming the dark side, making it livable. Much like Earth depends on electricity for everything from streetlights to homes, Proxima Centauri B's inhabitants might rely on advanced lighting systems to illuminate their world and maintain a habitable temperature in the perpetual shadow. Could these artificial lights indicate something much larger, perhaps an advanced technological society? The lights themselves might not merely be survival mechanisms. They could signal a civilization with remarkable energy management, engineering capabilities, and environmental control on a scale we've yet to imagine. Their very existence might suggest that Proxima Centauri B's inhabitants have mastered technologies that, to us, seem like science fiction. While emissions from Proxima Centauri B's dark side have been detected, there are significant challenges in fully understanding or analyzing them. First, the vast distance between Proxima Centauri B and Earth makes it incredibly difficult to isolate the faint signals from such a remote world. Even with the emissions we've identified, their faintness makes it hard to distinguish them from background noise. Proxima Centauri's solar flares and cosmic radiation further complicate the task, potentially obscuring the clarity of the signals we are trying to study. However, advancements in telescope technology are pushing the boundaries of what's possible. Instruments like the James Webb Space Telescope, JWST, and future telescopes like OIR are designed to focus on specific frequencies of light, including the infrared emissions that could originate from Proxima Centauri. These instruments are incredibly sensitive, and with their help, astronomers can isolate these emissions with greater precision despite the distance and interference from cosmic phenomena. Could Proxima Centauri B's natural emissions mislead researchers into thinking the planet is just another barren rock? Despite the breakthrough in detecting emissions, it's still possible that what we've detected is only the beginning. With the right advancements in technology, the true story may remain hidden beneath a layer of cosmic noise. While emissions from Proxima Centauri B's dark side have been identified, some of these signals might be natural phenomena, not artificial lights. Earth itself provides examples of such emissions, like the glowing auroras caused by interactions between solar wind and our magnetic field. On Proxima Centauri B, volcanic activity or atmospheric phenomena like auroras could produce similar glowing emissions. In fact, the planet's unique position, always facing its star on one side, could lead to dramatic volcanic or geothermal activity, releasing heat and energy into the atmosphere. This complexity could make distinguishing between artificial light and natural emissions especially difficult. Just as auroras here on Earth sometimes appear bright and magical, volcanic lightning or intense storm activity on Proxima Centauri B could emit emissions that might be mistaken for a city's glow. The faintness and peculiarity of these emissions could obscure our understanding of what's truly happening on the dark side. Could Proxima Centauri B be hiding something beneath its surface? What if these emissions aren't from a city but from a planet interacting with volcanic activity? The mystery beneath the planet's surface might be far more complex than we ever imagined, suggesting that Proxima Centauri B's dark side could harbor more than just a few lights. It might hold a dynamic, ever-changing environment. Proxima Centauri B's atmosphere could significantly affect the emissions detected from its dark side. If the planet has an atmosphere, it could act as a filter, modifying or absorbing specific wavelengths of light before they reach our telescopes. This means that even if artificial lights are shining brightly on the dark side, some of that light might be absorbed or scattered by the atmosphere, making detection even more challenging. The composition of Proxima Centauri B's atmosphere, whether it's rich in gases like carbon dioxide, nitrogen, or even exotic compounds, could alter how the light behaves as it passes through. For instance, certain gases can absorb specific wavelengths of light, changing the light's spectral signature when it reaches our instruments. This means that although we might be detecting something from the dark side, we might not fully understand its true nature due to the atmosphere's effects. What if Proxima Centauri B's atmosphere holds the key to understanding the emissions from its dark side? The way the atmosphere filters these emissions could provide insights into the planet's history, how it developed, what kind of environmental changes it has undergone, and whether it's capable of supporting life. By leveraging advanced telescopes like JWST and LOIR, we are on the brink of groundbreaking discoveries. These instruments could reveal faint emissions from Proxima Centauri B's dark side, potentially uncovering signs of life or technology on a distant world. With these breakthroughs, we'll answer questions not only about the planet's habitability but also about the possibility of intelligent civilizations beyond our own. The future of space exploration is exciting, and with every advancement, we draw closer to discovering whether we are truly alone in the universe. These discoveries will transform everything we know about the cosmos, and we're standing on the edge of something extraordinary. If you enjoyed this journey into the unknown, don't forget to like and subscribe for more updates as we continue to explore the mysteries of the universe. As telescopes like JWST and LOIR evolve, they will not only help us explore Proxima Centauri B but also provide critical insights into other distant exoplanets. Each new planet discovered expands the possibilities for finding habitable environments or even advanced civilizations. The combination of advanced instruments, innovative algorithms, and collaborative global efforts allows us to reach further into the universe than ever before. One of the biggest challenges ahead is interpreting the data. While we can detect light, heat, and other emissions, understanding their origin requires sophisticated modeling and simulations. Scientists will need to compare these findings against known natural phenomena and explore the possibilities of artificial origins. For Proxima Centauri B, this means determining whether the emissions come from geological processes, atmospheric reactions, or the deliberate efforts of a technologically advanced society. But this isn't just about detection. It's also about communication. If we identify signs of intelligent life on Proxima Centauri B, the next question becomes, can we communicate with them? This raises profound scientific, philosophical, and ethical questions. What would we say? How would we send the message? Would they even recognize it as communication, or would it be as incomprehensible as trying to understand a different species' language on Earth? Moreover, the discovery of extraterrestrial civilizations could completely redefine our understanding of the universe and our place in it. It might force us to confront questions about how we, as humanity, interact with other intelligent beings. Would we strive for peaceful collaboration, or would fear and uncertainty guide our actions? The answers to these questions will shape the future of space exploration and human civilization. On a more technical level, the detection of artificial lights or technology would also influence our advancements here on Earth. Studying the engineering marvels of an alien society might provide inspiration for solving some of our own pressing challenges. Whether it's creating sustainable energy systems, managing planetary resources, or developing new technologies for space travel. Finally, this search is not just about discovery. It's about hope. The possibility of finding intelligent life somewhere else in the cosmos offers a vision of the universe that is teeming with possibilities rather than isolation. It's a reminder that humanity's journey is far from over, that the cosmos holds secrets waiting to be uncovered, and that our ability to explore and innovate is limitless. As we continue to refine our tools and expand our reach, one thing is certain: the search for extraterrestrial life is no longer confined to science fiction. It is becoming a defining pursuit of the 21st century. Whether we find signs of life on Proxima Centauri B, another exoplanet, or even within our own solar system, the discoveries we make will forever change how we see ourselves and the universe we call home.